This is a video on how to set up the MPLAB X IDE and PIC It3 clone programmer to program the PIC MCUs needed for the 1088XEL motherboard. I'm only going to talk about that function of the MPLAB X IDE software. I'm sure that there are other videos that go into depth on the usage of the IDE to develop for various PICs. I'm just not going to go into that. There are two basic methods of using the IDE to program the PICs. The programmer to go is the one we're going to be talking about. It's best used to program multiple PICs of the same type with the same firmware. The single shot option is best when you are only doing one of each PIC. I'll try to do another video on that. It's very similar, just a few differences. I'm assuming at this point that you have connected the PIC It3 to a powered USB hub or a free USB port on your computer. I'm also assuming that you've been successful in installing the MPLAB X IDE to your computer. I'm currently using Windows 10. I did not have any problems installing the software, but your mileage may vary depending on your particular setup. Finally, you need to have downloaded the 1088XEL PICs firmware from MyTechControl's website and expanded the zip to a folder on your PC. I currently have that expanded folder in my MPLAB folder on drive D. You can put it, pretty much wherever you want to put it. One thing I noticed in using the software, it seems to be very erratic in how it responds to my mouse clicks when choosing menu items and checkboxes, etc. Not sure if this is the problem with the program or my setup. However, it is the only program that I seem to be having this problem with. So I'm inclined to believe it is a problem with the software. It is more of an annoyance than anything else. Okay, let's start up the program. So let's close this and start up the program. Once it fully loads, you will see various panes with information in each one. This is the start page for MChip. They also have a store that you can buy stuff from. This is below it is the output and status window. If you currently have a project selected, this is where you will see the various information on the configuration settings and so on. And then up here you'll see the list of projects that you currently have set up. Right now I already have set up the TK2OS PIC. We're going to be doing the mouse Atari. It uses the same type of PIC, just different firmware. So first of all, we'll be going to the File menu item, go down to where it says Import, move over to where it says Hex ELF pre-built file, and left click on that. This should bring up the import image file dialog window. Now we need to tell the program where the hex file is for the PIC. Click on the Browse button, and looks like we're still in the TK2 OS firmware folder, so let's click up one level. There we go. Now here's our mouse Atari firmware, so we'll double click on that. So we're in that folder, and here's our hex file right here. So we'll select that, then click on the Open button. Now one thing you want to make sure of is that under your hardware tools you see the PIC It3 listed. If you don't see that, then you've got a problem with either the communication between the PIC It3 programmer in your computer, or the installation of the software did not go according to plan. Alright, the next step you want to make sure of is that we have the family set correctly. In this case, it's correct, it's the same, but I'll go through the process so that you know how to select what you need. All of the PICs in the 1088 XEL motherboard project are of the same family. They're considered mid-range 8-bit MCUs. So go ahead and select that here. And then now you have access to choose this specific PIC that you are going to be using. We're going to be using the PIC 16F 1847. So you'll need to scroll down until you get to that. And a little bit more. There we go. Right there, 16F 1847. Alright, now we're still showing that. That's highlighted. So we're going to go ahead and click on the next button. Now I like to try to keep everything in the same folder. So what I do here is I just click on the Use Project Location as the project folder, and it basically puts everything in the same place. Okay, so we're finished at this point with this. Okay, now we have the project built. We need to make sure that the project that we want to work with is the one that's highlighted. Again, it's not highlighted here, so we need to highlight it. Make sure we're seeing the representative information here, and then go ahead and click on the properties, project properties glyph here. Alright, so we've got another dialog box. We want to make sure that we have the PIC 3 selected, and then there's 3 options that we're going to go into and configure. The first one we're going to do is the program options. And I'm not quite sure why, but this is what comes up by default. And it's not actually recommended. This is the one that's recommended and the one that you should choose. Don't ask me why they use the other one as a default. They chose to do it for whatever reason. Okay, now the next option we're going to configure is the power. And basically what we're going to do here is we're going to tell the PIC 3 programmer to supply the source voltage for the PIC chip. In this case it's 5 volts. So we've got that selected and turned on. Now the final thing we're going to go into is a programmer to go. And here we've got to tell the software what the name of the image is that we're going to be programming to the programmer to the PIC 3. So in this case it's going to be the mouse Atari. Alright, we're going to be applying it, and then OK. Alright, now that completes the configuration of the IDE for what we want to do. The next step involves actually programming the PIC 3 programmer so that it goes into the programmer to go mode. So we're going to go ahead and go up here, and we're going to select the programmer to go mode. Alright, now that we're getting a message, and this you may see if you've used the PIC 3 programmer in Programmer to Go mode before. It's basically saying, hey, I'm already in that mode. What do you want me to do with the image that's already on the PIC 3? And in this case, we want to replace that image. So we'll go ahead and tell it no. And then this message may come up. It's basically warning you that it's not very healthy for a 3.3 volt device to be fed 5 volts. Are you really sure this is what you want to do? Since at this time we're not actually programming the PIC, we can safely say okay. If you were going with a direct programming, you would definitely want to make sure that the PIC that you are programming is a 5 volt tolerant chip. Otherwise, you let the blue smoke out. Okay. Alright, now this is an error that you may see. Essentially what's occurred is that the USB hub or the USB port that you have the programmer plugged into cannot supply the 5 volts. In my case, I've got it plugged into a powered USB hub. And the solution to this was to simply unplug the other USB devices that were already plugged in. That allowed the port that the programmer was plugged into to actually supply the necessary 5 volts. So I'm going at this point to unplug the additional USB devices. We'll try plugging or programming the PIC again and see what happens. Okay, I've got it unplugged. We'll go ahead and try it again now. Okay, we get this message again. That's okay. Alright, now it has enough voltage. And it is now complete. The software has programmed the PIC 3 programmer to function in Programmer to Go mode. And that's all we're going to cover in this particular video. The next video deals with connecting the Programmer to Go, or the PIC 3 programmer, to an adapter board, and using the Programmer to Go mode to program a particular PIC. Thank you for watching.